Okay, so let's continue then. So we talked about layers. Layers provide services to layer above it, using services below it. There are two main models for how to structure this, the OSI model and the Internet Reference Model. So let's talk about those. And let's talk about the clean, well thought out model, theoretical model, which is not used so much in practice, not at all as far as I know, has 7 layers, okay? And each layer provides different things. So at the bottom here, we have the physical layer which transfers bits over a physical channel. Data link layers, we transfer frames, which are blocks of bits. We can think of that as a packet of bits over a single link. We have the network layer that transfers packets over several links. We have a transport layer, which is an end-to-end transfer of messages. And end-to-end here means from one host to another host on the network. And there are many, many links and nodes in between. Okay. We have the session layer, which deals with dialogue management, error recovery. Presentation layer, which deals with conversion between different data types and other things. And then the application layer that we actually talked a little bit about earlier, which provides services frequently used by application software, like DNS and things like that. Okay, so it was realized quite soon that layer 6 and layer 5 were quite thin. They didn't have much of content in it, and it made little sense. Remember again, this is a divide and conquer strategy, right? So which is nice because you have modularity. But if you divide up the problem in too many small sub-pieces, it actually becomes bad, right? Because you get inefficiencies and things like that. So it was quickly realized that layer 5 and 6 basically didn't have enough functionality to really justify that they should be their own layers. So layer 5 and 6 are typically merged into layer 7. So all of that is now called the application layer. But for historical reasons, that kept the number 7. So sometimes when people talk about layer 7, they mean application layer. But then there is no layer 5 and 6. They are absorbed in layer 7. So the layer below layer 7 is actually layer 4, right? Okay. It's not super important, but that's how it is, right? So this is the, I mean, what's on the right-hand side here is basically what we typically when we talk about the OSI model, we talk about these things and this one, and it sort of merged the functionality of these two layers in it. Okay. Protocol message structure now. So a protocol message, remember a protocol message goes from one protocol entity at one node to the corresponding layer and the corresponding protocol entity at another node. These interchange messages. These messages are typically consisting of two things: a header, data, and sometimes a trailer. Okay, and we can think of the header as being control information, addresses, other things which is needed for the protocol to do its stuff. Okay, so this is control information. Data is the information that the protocol got from the layer above it. So this is something that the layer has been asked to transfer. Okay, so we can think of this as the payload, right? If we do a envelope or regular mail type of analogy here, this would be the actual letter, right? And then that would be wrapped into an envelope, and on the envelope we would have addresses and a stamp and so forth, right? So the letter, this is what's contained in the envelope, and this is what's outside on the envelope in order for the protocol to do its stuff. So the postal office knows what to do with this envelope. Okay, so header, data field, and sometimes a trailer. And typically we think that this is the first bit in the packet or the protocol message, and this is the last bit. Okay. And here comes, this is actually a quite important slide. So if if you want to pay attention to something in this last half hour, this is one of the things that you really want to concentrate on. So, how does this work with these messages? First of all, the application program. The application program here needs to transmit data. So the application program here would like to send some data to the application program here. How does it do it? This application program then asks a suitable protocol in the application layer to do its work. Okay? Please send this data to this application program. The protocol here accepts the information from above, which is the application data, and then puts a header on top of that, puts a header in front of the application data you got before, and this is actually the message which is sent over to the other application layer protocol here. Okay, so the payload is unchanged, and here is the specific information, control information, that the protocol in the application layer here needs in order to do its job together with the corresponding entity at this point. Okay, so this is fine. Now the application layer here, to do its job, to transmit this information, it uses the services of the transport layer. So it pushes down this piece down to the next layer. For the next layer, everything here is payload. Okay? It's something it's asked to transmit, so it shouldn't mess with this at all. But to do its job, it needs to put on its own control information. The transport layer header. Application layer header, transport layer header. Okay? Now, to do this transport between the transport layer protocol here and the transport layer protocol here, it uses the services provided by the network layer. Okay? So this data is then pushed down the stack, and a new header is on top of that. So from the network layer's point of view, everything here is payload. Right? And then it just adds its own control information on this. So the network protocol should not mess with this data at all, should not use it, not modify it, don't do anything with it, just transfer it. And to do that, it needs to put on its own control information. Okay, so you can imagine what happens in a network layer. Basically, the same process repeats. One takes the information from the layer above it, push it down, don't change it, add the header to it. And for reasons which is not super clear now, but the data link layer typically adds a trailer to this also. So it has two pieces of control information, one in the beginning and one at the end. All right, and then it actually pushes it down to the physical layer, and the physical layer now actually does the work, right? It transmits the information over a physical channel, like a cable, radio channel, whatever. Okay, so this process is called encapsulation, where data from the layer above is encapsulated into a message on the next layer. The message on this layer is encapsulated into the message of the layer below it, and so forth. So as we go down in the stack, the number of bits increases by each layer adding its own control information to the data that needs to eventually be transmitted down at the physical layer. Questions? Okay. So what happens at the receiving end is the opposite, right? So these bits are then transmitted over to this physical layer, and when it pushes the data up here, it pushes all the bits up, okay? But from the data link, when it pushes it up to the network layer here, it strips off this and then presents to this network layer the payload of the data link layer, which is exactly this message. Then the network layer, when pushing the data up to the transport layer, strips off the network layer header, and the transport layer here basically gets this message, right? And so forth. So the logical information, the logical exchange of messages here is implemented by adding headers and removing them on the other side. That's called decapsulation. Encapsulation and decapsulation. And this is a fundamental principle of protocol layering, right? And the fundamental principle is that don't ever mess with the data that you get from above. Don't use it. Don't assume that it has any type of format. Just takes it. You should not change that data at all. And whatever you need to do your job, just add headers to do this. Okay? Questions? No. Okay. So, yeah, at the receiving end, everything. Okay. So let's look now at one particular layer and introduce some terminology which is used in the OSI model. And this terminology is actually not found in the course book. So this would then serve as the reference information for this, whatever is on the slides here. And of course, as I said many times before, Google is your friend here if you want to know more about these things. But when it comes to the OSI protocol structure, then it's always like this, that sorry, let's do this. Communication between peer processes. Okay, so what are peer processes? These are the two pieces of software on each end of the connection that's executing the protocol. So this is what we called protocol entities before. The communication is virtual, right, in the sense that there is communication between them, but the physical one actually goes through the layer below it. So layer n+1, say layer 4, transfers information by invoking services provided by the layer below it, that is layer n. So if n+1 is 5, then n is 4. So layer 5 uses layer 4 uses layer 3, and so forth. Services are available at some type of software construct called service access points, which has unique identifiers. So an HTTP server process passes information back and forth to a TCP process. So this is at some layer, the application layer, and this is at the transport layer. So HTTP process sends information back and forth to the TCP process via a specific transport layer service access point, which is called port 80. I will show you a diagram of this later on. Okay, but basically, service access points is where data goes from one layer to another layer in the same node. So each layer passes then data and control information to the layer below it until it reaches the physical layer, and then the data is actually transmitted. The data which is received from the layer above is called a service data unit, or SDU. Service data units are encapsulated in PDUs, and PDUs is protocol data units. Okay. So we have service data units and protocol data units, and I will very shortly explain how these are related to each other. Okay, here. Okay, so if there is the second thing from this lecture that you should try to concentrate on understanding is this figure. Once you have decoded this and understand the various pieces of this, you're a long, long way towards understanding what protocols and layers and services are. So in this complicated graph here, we have layer n+1. So for instance, this could be layer 5. So let's let's not do layer 5 here. Let's do, so suppose that this is layer 3 and this is layer 2, just to be concrete. Okay. Now, in layer 3, there are software which is running on one node and software which is running on another node, and they exchange information back and forth here. This is the logical flow of information. On the layer below it, layer 2, there is another software process which is interacting with another software process on the other node, interchanging messages like this. The processes at the same node interact over this service access point. Okay. So this is how data goes up and down the protocol stack. Here is the logical flow of information between protocol entities at the same layer, but at different nodes. Okay, so the first thing to do here is to there is this entity has the need to send a protocol data unit to the other side. Okay, so along this edge there is a protocol data unit that needs to go from here to here. Okay, so how is this done physically? So this is the virtual connection, but the physical connection is, why is this? Okay, so let's do this. There is some problem here. Then it takes this that actually go logically like this, physically goes down the stack first. So here we have the same bits as we have up here, and then it's transferred over the service access point to get to this point. So what happened now? From here to here, we just went over the border between one layer to another layer. It's exactly the same bits here as here, but from the perspective of layer 2, what comes above is a service data unit. Okay, it is the payload that layer 2 should transmit. Okay, from layer 3 perspective, this is a protocol data unit that needs to go from here to here in order to do its job. Okay, so here it only is change of names. So these are identical things, just illustrating two different perspectives. From layer 3, this is a protocol data unit. For layer 2, this is a service data unit. Okay. What happens then? Well, then this protocol data unit is encapsulated. Okay. It's encapsulated in the protocol it's encapsulated into this form, where here's the payload and here's the header, and the header is the header that pertains to layer number 2. And then it logically goes over this connection. But the physical thing is, of course, that whatever this is needs to be transmitted down the stack. Okay, so here again, we have a protocol data unit at layer 3. It becomes a service data unit at layer 2. The service data unit of layer 2 is encapsulated in a protocol data unit for layer 2. Okay, which consists of a header and the payload. So here is the actual data, and then it goes down the stack here. Eventually, it goes down, and at some point, it pops up from layer 1 at the other side. So these bits, the bits that are here, are exactly the bits that pop up here, if everything works well, right? Now, so what is the process at the receiving end? Well, it's to do decapsulation. Okay, so this protocol data unit, which is exactly this one, is then transferred up the stack by getting rid of the header. So here we have the service data unit, and whatever is in here is in here. It's exactly the same bits, if everything worked out well. It goes over the interface, and then it changes name to service data, protocol data unit, because now we're in layer 3, and this bits here are exactly the bits that are here. Right. So what we have achieved now is that this protocol data entity would like to communicate with this one with these bits. Okay, so the logical flow of bits are here. The physical flow of bits is down the stack, over the channel, and then up the stack. And going down the stack, we add headers, we do encapsulation. Going up the stack, we get rid of the headers, decapsulation. So this is the principle. Questions? Okay. From my experience, what is the most tricky part here is the terminology, right? That in a layer, we are exchanging protocol data units. So protocol data units goes over the logical connections. They change name as they go over the interface here, just to illustrate that for layer 2, the protocol data unit of layer 3 is the service data unit, the payload it needs to handle. Okay. So to distinguish these two things terminology-wise, even though they are exactly the same bits, is sometimes a tricky thing, right? But if you stare at this picture for sufficiently long time and try to, argue with your friends or with yourself what's going on here until you figure this one out, please do that, and then you will be a long way towards understanding this. Okay. Now, if we clear all the, okay. This is problematic. Okay, so we've done this. Now, suppose now that this entity here would like to return some information to the other entity. Basically, we do the same process, but in reverse. So whatever data that this entity would like to transfer in this direction goes down the stack on this side and then up the stack on the other side. So the first thing to do is that whatever bits we had here, we copy them down here, and then it goes down here, and then it becomes a logical flow of information this way, which is actually physically going down here and then coming up here, and then getting decapsulated and then transferred over the interface. And then now, since we now were dealing with this one, these are exactly the same bits. Okay, so it's just the process can go in both directions. Okay, now questions. Okay, please spend some time on this. Protocol data units, service data units, service access points. Okay. Encapsulation as we go down, decapsulation as we go up. All right. Okay, so let's continue then. Protocol data unit names. There are specific layer-specific names for PDUs sometimes used when we really would like to illustrate that. So for the application layer, they are transmitting, the application layer entities are transmitting PDUs between each other, and these are called messages. For the transport layer, they are called segments. For network layers, they are called packets. For link layer, they're called frames. For physical layer, they're called bits. Okay? Sometimes we find it illustrative to really use the names here to illustrate that there are different things. But we will mostly be sloppy and say just a packet when we talk about a block of bits. Okay? So even though a packet is actually reserved for the protocol data unit used in the network layer, we will often say that we deal with packets on the link layer and actually packets on the transport layer also, and even on the application layer. One should also, in practice, many physical layers here do more than transfer bits. They actually transmit blocks of bits. But we will see if Wi-Fi, for instance, is using a block of bits in its physical layer. We will see more about that later on. Okay, now let's talk a little bit about services and what they basically to introduce a little bit of terminology. This is a fairly important concept, which is connection-oriented and connectionless services. You remember back that we talked about circuit switching and packet switching earlier. This is somewhat similar to that, but a little bit different. Okay, there are subtle differences between these. Frequently, these concepts are confused. It's good for you if you can keep them a little bit separate, and I'll try to explain what's separate. Okay, so we provide a service, and suppose we have a service at layer n, okay, and then that is provided to the layer above it. So we're layer n, and we provide a service to layer n plus 1. So the service we provide can be connection-oriented or connection-less, and a typical example of a connection-oriented one is TCP. And TCP, what it does, it creates a connection between the two communicating entities before actually transmitting data. So we create a logical connection between the layer and service access points at both ends. We allocate buffers, agree on transmission parameters, and so forth. And then data is actually transmitted. And once we are done, we tear down the connection between when the communication session is done, release buffers and resources again. So if you remember what we did earlier is that we did a TCP connection request. And then we got a TCP connection confirmation before we can start to transmit data. So this is the setup phase. And then we had the transmission phase. So we exchange data. And then when we're done, we use a connection release. Okay. So connection-oriented services, before actually we can transmit any data, remember when we did the web server example, before we even can ask the web server to tell us something, we need to establish a TCP connection. So we ask the TCP layer, could you please provide me a connection to the web server? And the TCP then negotiates with the TCP at the other side to figure out, okay, if this is okay or not. And if everything is okay, we establish the connection, and then we can start to exchange data. Okay. A connectionless service does not do this. It simply just transmits data. So IP is an example of this. An IP layer, but the only thing it does is to push in data into the network and then hope for the best. Okay? So it doesn't even figure out whether there's the receiving node is even awake. right? It could be crashed, it could be offline, there could be a power outage or whatever. It does not connect with the other side before actually transmitting the packet. So again, we can have this idea about the telephone service where you actually provide a connection before you start to talk. Okay. Now, what's interesting is that the service type, whether it's connection-oriented or connectionless, does not necessarily need to depend on the service provided by the lower layer. So TCP is a connection-oriented service. Okay. So if I'm TCP, I'm providing a connection-oriented service to the layer above me. However, if I'm TCP, I also use IP, which is below me, and IP is not connection-oriented. Okay. So basically, I take a connection-less service, and I refine it into a connection-oriented service to the layer above me. Okay. Questions? Okay. Let me just do a few quick things here. Fragmentation and reassembly. If I'm a layer and the layer below, and I get 1,000 bytes from the layer above me, but the layer below me can only transmit 500 bytes per payload. Basically, what I need to do is to take these 1,000 bits, divide them into two parts, and send them separately. This is called fragmentation. On the receiving end, I get these two fragments, I glue them together before I push them up to the layer above me. This is called fragmentation and defragmentation. So IP does this, for instance. IP can receive messages which are quite long, and then depending on the service below IP, it sometimes needs to split it up into smaller pieces. This is called fragmentation. Of course, fragmentation and defragmentation should be completely transparent to the layer above it. So the layer above IP will not notice that IP fragments payloads. Okay? So the layer above it will never receive parts of the payload. It will only receive the full payload or no payload. Aggregation and deaggregation is more an issue about efficiency. So for instance, if I'm IP and I get each payload which is transmitted over the network requires a header. Okay, the header is fixed in size, so if the payload is small compared to the header, there's a loss of efficiency here. So sometimes a layer would collect many payloads before actually transmitting those, and at the receiving end, it would split up the payloads into separate payloads and send them up. It should also be completely transparent. Multiplexing means basically this. Yes. So let's finish off here and continue in maybe 15 minutes for the next lecture. Okay. I will talk more about multiplexing. Okay, so let's take a break.